Currently we are using the switches mostly, but we have to know about the hubs. So first we have a network hub explained. After that we know about the network bridge. What is the network bridge? After that, network switches. What is the network switches? Network routers like Cisco routers, Juniper routers, and other vendors routers. Half duplex and full duplex. We also know about the half duplex and the full duplex. IEE Ethernet standard. IEE stand for Institute of Electronic and Electricals Engineer. So the all type of devices, network devices are standards. That standards define the IEE. And the last one we have the Cisco three-layer hierarchical model. We also know about the Cisco layer hierarchical. That means the networking hierarchical models. So networking has the basically three layers. So we discuss about in this video today. So we have the first one, network hubs. A hub serves as a central point to which all of host in a network connect to. That means the hub is work as a central device in a network. It is an OSI layer first device. OSI we have already discussed in my first video. So hub is used in a OSI layer first and has no concept of Ethernet frames or addressing. That means the hub hasn't concept hasn't save any addressing and the Ethernet frame, as well as switches are addressing the MAC address of the host, but hubs has no this type of features. It simply receive the signal from one port and send it out to all other ports. That means it is simply plug and play. He receive it's receive a signal from one port and it broadcast the all other remaining ports. Here is an example for 4-port Ethernet hub. You can see here the Netgear hub that is 4 ports. So that means if we going to insert a incoming signal in a port number one, that means the port number one is a incoming signal port and the rest are is the outgoing broadcast ports. As mentioned above, hub have no way of distinguishing out which port a signal should be sent to. Initiated an electrical signal is sent out each port. All nodes on the network will receive data and the data will eventually reach the correct destination, but with a lot of unnecessary network traffic. That means the all ports send the broadcast signal, send the data to all connected hosts that have not actually required. So this create the network traffic very much. So you can see here, here is a device that is connected to four other computers. So in the example above, you can see that the hub has sent out the received signal out all other ports except the incoming ports. That means you can see here the black arrow show that the computer send the signal to the hub and hub the send the signals to other three computers accepting the incoming port. That means it's not send the that port there the signal is coming. It's send the signals to another ports where have no signals are coming. So have are therefore considered obsoleted and switches are commonly used instead in modern LANs. Hubs have numerous disadvantages over switch, such as they are not aware of the traffic that passes through them. They create only one large collision domain. A hub typically operates in a half duplex. There is also a security issue with a hub since the traffic is forwarded to all ports except the source port, which make it possible to capture all traffic in a network with a network sniffer. Hub are also known as a multi-port repeaters because that the basically what they do repeat the electrical signals that comes in one port out all other ports except the incoming ports. Next, we have the network bridge explained. Network bridge, you can see here the network bridge is a device that divides a network into segments. That is, the network bridge divide a network into segments. Each segment represent a separate collision domain. That means the each separate has the a special domain. That means a special network class, network IP, you can see. So the number of collision on the network is reduced also because each collision domain has its own separate bandwidth. A bridge also improve the overall network performance. A bridge work at the data link layer. That means the bridge works in a OSI second layer, data link layer, layer 2 of the OSI model, just like a switch does. It inspects incoming traffic and decide whether to forward it or filter it. Each incoming Ethernet frame is inspected for destination MAC address. If the bridge determines that one destination host is on another segment of the network, it forwards the frame to the that segment. So let's see example. Consider the flowing network. So you can see here the networks have the two different hub 1 and hub 2, and the hub 1 connected with the host A and host B computers, and hub 2 connected with the host C and the host D computers. Hub 2 have a collision domain 2, and hub 1 have a domain 1, and in between you can see the bridge device is connected. So in the example above, we have a network of 4 computers. The network is divided into segment by a bridge. Each segment is a separate collision domain with its own bandwidth. Let's say that a host A wants to communicate with host C. Host A will send the frame with the host C destination MAC address to the bridge. The bridge will inspect the frame and forward it the segment of the network host C is on. That means if computer A wants to communicate with the computer C, then the first computer A send a data to the bridge, and the bridge identify the MAC address of the host C, and the bridge make the communications between those computers. Network bridge offered substantial improvement over network hubs, but are not widely used anymore in modern LANs. Switch are commonly used instead. Here is why. I have already told you, because the no in a current networking, in a current network interface, hubs are not used very much. It's a old fashioned networking where the hub and bridge are used. Currently in a modern LAN we are using the switches. Why we are using the switches? Because the most bridge have only 2 or 4 ports. A switch can have 10 or even 100 of ports. That means if we switch has 10 or 10 port switches, 5 port switches, 100 port switches, 24 port switches, but bridge have mostly 2 and 4 ports. Bridge are software based while switch are hardware based and use chip when making forward decisions, which makes them much faster than bridge. Switch can have multiple spanning tree instance, bridge can have only one. Switch can have multiple broadcast domain over LAN. Next we have the network switch. Here is the Cisco switch. Let's see the what is the switch. Just like hub and bridge, a switch is used to connect multiple hosts together, but it has a many advantage over them. Switch is an OSI layer 2 device, which means that it can inspect, receive traffic and make forwarding decision. Each port on a switch is separate collision domain and can run in a full duplex mode. Full duplex mode, that means is send and receive data with a signal with a single ports. A switch manages the flow of data across a network by inspecting the incoming frame's destination MAC address and forwarding the frame only to the host for which the data was initiated. Each switch has a dynamic table called the MAC address table that maps MAC address to port. With this information, a switch can identify which system is sitting on which port and where to send the receive frame. That means the all switch have a MAC address table. That means the all switch have a record to to its all hosts. So the switch is easily identified the host MAC and send data to its related device. Here we can see the four domain collision network. To better understand how a switch work, consider the following example. As you can see from the example above, host A is trying to communicate with host C and send a packet with the host C's destination MAC address. The packet arrived at the switch, which look at the destination MAC address. The switch then searches that MAC address in its MAC address table. If the MAC address is found, the switch then forward the packet only out of port connected to the frame destination. Host connected to other ports will not receive the frame. That means if the switch recognize the MAC address where the data have to go on, then the switch only send the data to related device, not to any others. So first the switch have to identify the MAC address in his MAC address table. Next we have the network router. Let's see the network router. A router is a network device that routes packets from one network to another. It is usually connected to two or more different networks. When a packet comes to a router port, the router read the address information in the packet to determine out which port of packet will be sent. For example, a router provides you with the internet access by connecting your LAN with the internet. That means the before the router, the internet is a different network, and after the router, your local network area is a different network. So that means the router is connecting the two different networks. That means the internet network and your local network. Router is the most commonly on OSI layer 3 device since its forwarding decision is based on the information of the OSI layer 3. The destination IP address routers divide broadcast domains, provide full duplex communication and have traffic filtering capabilities. The picture below show the typical home router. This is the typical home router. You can see it is a modem where we can use in our broadband connection, our fiber connection, fiber broadband connections. So this is a router pic. Here, if two hosts from different network want to communicate, they will need a router in order to exchange data. Consider the following examples. As I already told you, if there is a two different type of networks which have the one have the A class IP local area LAN IP is a class, another have the local LAN IP is the B class, and a C class. Then we need a router between the between in two networks to communicate each other. We have a network of three hosts and a router, as you can see in the above example, that each computer is in different network. Host A wants to communicate with host B and sends the packet with the host B IP address. Host B IP address is the 10.0.0.0, sorry, 10.0.0.20 in a 24 subnet. That means 24 subnets represent 255.255.255.0. We brief this all net IPs and subnet in my coming in videos. Here is just an example. The router received the packet, compare the packet destination IP address to the entire in its routing table and find a match. It then send the packet out the interface associated with the network 10.0.0.024. Only host B will receive and process the packets. In fact, host C will not even be aware that the communication took place. So that means, so we can say the router is an intelligent device in a network which is used in a layer 3 OSI, which is used in a OSI layer 3, and it's used to communicate between two different networks. Now we have the half duplex and a full duplex. Let's see, in telecommunication, a duplex communication system is a point-to-point system of two devices that can communicate with each other in both directions. These two types of duplex communicate system exist in Ethernet environment. Half duplex, a port can send data only when it is not receiving data. In other words, it cannot send and receive data at the same time. It's called a half duplex device. Network hubs run in half duplex mode in order to prevent collision. Since hubs are rare in modern LANs, as I already told you, hubs are not much used in our present networking. The half duplex system is not widely used in the Ethernet network anymore. Full duplex, all nodes can send and receive on their ports at the same time. This is the full duplex. In other words, you can say the data send and receive in the same time is called a full duplex. There are no collision in full duplex mode, but the host NIC and the switch port must support the full duplex mode. That means in the full duplex communication, we need the network interface card NIC and the switch port is capable to run the full duplex. Full duplex Ethernet use two pairs of wires at the same time instead of a single wire pair like half duplex. Full duplex use the two pair of cable and the half duplex use the single pair of cable in a network. The following picture illustrates the concept. You can see here's the hub, switch and a client. You can see the hub is sending the data switch with the NIC fast Ethernet 01. So it's only sending the data. That means the arrow is only go through the switch. So this is the half duplex, and you can see the switch and the host communicating each other with the send and receive both at the same time. So it's called a full duplex. Because a hub can only operate in a half duplex, the switch and a hub will negotiate to use half duplex, which means that only one device can send data at the time. The workstation on the right support full duplex, so the link between the switch and the workstation will use full duplex, with both devices sending data simultaneously. Each NIC and switch port has a duplex setting for all link between host and switches or between switches. The full duplex mode should be used. However, for all links connected to a LAN hub, the half duplex mode should be used in order to prevent a duplex mismatch that could decrease network performance. In Windows, you can set up duplex setting in the properties windows of your network adapter. Here is the example how you can set the full duplex and half duplex in your network. So first you have to go in your network property center where you have find your drivers, whatever it is, the Wi-Fi and the LAN, and then go in properties, and in advanced section you check here the speed and duplex and value auto negotiate, and you can change the value of the 100 Mbps half duplex and 1 Gbps to full duplex. It depends on you. So let's see how can you change the duplex in a network. So we have to go first in our network connection. So let's see here, open network and internet setting. You can see the properties, but we have to go in a Ethernet section, and here is the change adapter setting. In a change adapter setting, as you click, I have a Ethernet, but I am currently connected with the Wi-Fi. So we have to click on the right and go with the properties. In the properties, you can see here I have the driver of the Qualcomm wireless adapter and configure. Click here on the configure, and here we have the advanced option. In advanced option is the wireless mode value. You can check here romance roaming aggression preferred band, you can see here the bands, network address, you can see here the network address, and the DO packets. So I think this is a Wi-Fi. So I am this devices are using the Windows 10. So I have already the all latest devices come with the full duplex. So there is no options to change the hub and full duplex, but you can do as similar I do. So next we have the IEEE Ethernet standards. Ethernet is a defined in a number of IEEE. I have already told you IEEE stands the Institute of Electrical and Electronics Engineer. IEEE 802.3 standards. These standards define the physical and data link layer specification of the Internet. The most important 802.3 standards are: first, the 10 best T IEEE 802.3, 10 Mbps with category 3 unshielded twisted pair UTP wiring up to 100-meter long. UTP stands for the unshielded twisted pair. It is a LAN cable. In a 10 best T standards, we have the 10 Mbps with the category 3 speed. That when we connect the network with the LAN, so the LAN wire is a different type, like it's a cat 1, cat 2, cat 3, cat 4. The cat define the category. So with the category 3 10 Mbps with the wire length is a 100 meter. 100 best TX, we have the known as a fast Ethernet, use category 5, 5E or 6 UTP wiring with the 100 meters long. 100 best FX, a version of fast Ethernet that use multi-mode optical fiber up to 412-meter long. 1000 bit CX, use copper twisted pair cabling up to 25-meter long. 100 base T gigabyte Ethernet that use category 5 UTP wiring up to 100-meter long. 1000 base SX 1 gigabyte Ethernet running over multi-mode fiber optic cable. 1000 base LX 1 gigabyte Ethernet running over single mode fiber. 10 GB T 10 Gbps connection over category 5E, 6 and 7 UTP cables. How the first number in the name of the standard represent the speed of the network in megabytes per second. The word base refer to baseband, meaning that the signals are transmitted without modulation. The last part of the standard name refers to the cabling used to carry signals. For the example, 1000 base T means that the speed of the network is up to 1000 Mbps. Baseband signaling is used and the twisted pair cable will be used. T stand for twisted pair. So basically it's defined the Ethernet framework, Ethernet cabling in a network: 10 base T, 100 base T, 100 base FX, 100 base TX, 1000 base CX. So this is the IEEE standards of Ethernet. That means if we are going to set a network, if we are going to establish a new network connection, that we have to knowledge about the cabling, about the IEEE standards, so we can easily make the communication with the LAN cables. The last we have the Cisco 3 layers hierarchical. So let's see in a Cisco 3 layers hierarchical model, because network can be extremely complicated. We all are know the network is a very complicated things. It is not a simple thing. With multiple protocol and drivers technology, we have the multiple protocols in a single network. Cisco has developed a layered hierarchical model for designing a reliable network infrastructure. This three-layer model helps you design, implement, and maintain a scalable, reliable, and cost-effective network. Each of layer has its own features and functionality which reduce network complexity. Here is an example of the Cisco hierarchical models. You can see the Cisco have the three hierarchical models. First one is the core, second one is the distribution, and third one is the access. So core is a core and distribution. I think core and distribution used by the service provider, internet service provider, ISP, and the access we all have the our own computer access. So access hierarchy is used by clients. So description of each layer: access control user and workgroup access. Already I told you the access layer is used by the users. To the resource on the network, this layer usually incorporate layer 2 switches and access point the provided connectivity between workstation and servers. You can manage access control and policy, create separate collision domain, and implement port security at the layer. Distribution layer serves as a communication point between the access layer and the core. That means the access layer and the core layer, that means the distribution is the middle point of these two other layers. Its primary function are to provide routing, filtering, and WAN access, wide area network access, and to determine how packets can access the core. This layer determines the fastest way that network service requests are accessed. For example, how a file request is forwarded to a server, and if necessary forwards the request to the core layer. This layer usually consists the routers and multi-layer switches. So in a distribution layer we have the router and switches as per the Cisco layer hierarchies. Last one we have the core, also referred as the network backbone. This layer is responsible for transmitting large amount of traffic quickly. The core layer provides interconnectivity between distribution layer device. It usually consists of high speed device like high end routers and switches with redundant links.